Good morning, everyone. What I want to try to do today is something I would do normally in the classroom is distinguish the difference between what is distance and what is displacement. So what is the difference? Distance is the total amount that is traveled. We add up the vectors. So if I traveled 5 miles down the street, took a right on Exchange Street and traveled 8 more, well then my distance would be a total of 13. I would add up 5 plus 8. That's distance. So what is displacement? Displacement is the distance from the starting point to your finishing point in a straight line. And that's the key, a straight line. So if I'm starting here and I went up the street, took a right, came back down, and finished over here, then my displacement would be from start to finish. So I would record or measure from start to finish. So this is distance. The dotted line is displacement. So what we're going to try to do is calculate distance and calculate displacement. Now to calculate distance, like I said earlier, we are just adding up the vectors. Okay, so you're going to add up all vectors. And a vector is just a line represented with how far you go. So if I'm starting here and I travel 5 north, 6 east, and 2 south, I would add up 5 plus 6 plus 2 for a total of 13. That would be my distance. 5 plus 6 is 11, plus 2 is 13. Now, how do I calculate displacement? Calculate displacement, we're going to use a mathematical formula called Pythagorean's theorem. You may have heard of it. That is the famous a squared plus b squared equals c. Okay? The c, in our case, is going to be displacement. However, we're going to tweak it a little bit. We are going to say it's a squared plus b squared equals the square root of a squared plus b squared. This is how we are going to use it to calculate displacement. So let's go over a couple of examples on how we would do that. Okay. So I'm just going to kind of run down a list of operations, so to speak, to make sure that you calculate it the right way. So like I just said on the previous page, the formula for displacement is a squared plus b squared equals the square root of the total, a squared plus b squared. Now right now, you're probably saying, well, what is a and b? Well, we'll figure that out in a minute. I'll show you with a couple of examples. Right now, I just want to run down a list of directions in order to calculate it. So the first thing I'm going to do when I get a problem is I'm going to map out the distance traveled from start to finish. Then I'm going to label my map with A and B. Okay? So I want to know in my diagram which vector is A and which is B, because that's what we're going to need for this particular problem to calculate displacement. Then I'm going to square whatever A is and whatever B is. So if A is 5, well, 5 squared is 25. 5 times 5. If A is 8 and I square it up, 8 times 8 is 64. That's what squaring is, just as a quick review. Then I'm going to use the square root function of your calculator. In some phones, you may have to turn it sideways to get the square root function, all right, to get the displacement. So here we have example number 1. David walks 7 meters north. Then he walks 5 meters east. What is his displacement? So I'm just going to draw out a basic diagram. David walks 7 meters north. I'm going to label that A. Then he walks 5 meters east, which is my second vector. Okay, I'm going to label that B. And as you can see, we kind of have a right triangle here, but we'll get into that later on possibly. All right, so I want to figure out what the displacement is, but I can also figure out what the distance is. The distance is 7 plus 5. So the total distance here is 12 meters. But now I want to calculate the displacement. What is the distance between where David started and where David finished? Okay, this is C. This is displacement. So I'm going to go back to my formula, A squared plus B squared. We said that A was 7. So 7 squared plus B squared, which is 5. I labeled 5 as my B vector. So 5 squared. All right, so we set it up. All right. 7 squared is 49. 5 squared is 25. So we're going to add that. And remember, I'm going to put the total of A squared plus B squared inside the square root, just like I did up here. 49 plus 25 is 74. So what is the square root of 74? Take the calculator, square it up. Okay. Depending on the calculator, you might have to put the square root first or the square root at the end. With mine, I would enter it the square root and then followed by the number of 74. And when I do that, that gives me a distance of 8.60, which is my displacement. Okay, so here would be 8.6. So even though I traveled a distance of 12 to get to where I needed to go, the actual displacement was only 8.6 meters away. The displacement is never greater than the distance. Okay, let's try another example. Amy rides her bike 10 miles south, then completes the run by riding 5 more miles east for a distance of 15 miles. What is the displacement? Well, let's just draw a quick diagram. All right, 10 miles south. So here's my starting point. All right, starting point. I'm going to draw just a vector line and label it 10. Okay, to represent 10 miles south. Then completes the run by going 5 more miles east. So I'm just going to draw another line representing the eastward motion. All right. So there's my distance traveled, 10 plus 5. So my distance here is 15 miles. What we want to do now is calculate the actual displacement. Okay, and the displacement is from the start to the finish. And that's going to be C. Okay? All right, so using the formula, a squared plus b squared equals the square root of the total to give me my displacement. I would set it up this way. All right, first thing I do, label. Doesn't matter, A and B, so that I know. All right, A is 10 squared plus B squared, so plus 5 squared. Okay, 10 squared is a 100. 5 squared is 25. For a total of 125. But we're going to take the square root of that. So now the square root of 125 is 11.18. So that's my displacement. But in this case, it's going to be 11.18 miles. Okay. Again, displacement less than the total distance traveled. Now somebody's just saying, well, why wouldn't he just walk a straight line? Well, maybe there's a lake that he had to walk around, okay, to get to his friend's house that he could see across the lake. Okay. All right, and last example for the day. An ant travels 1 meter west, turns right, and travels 2 meters north. What is the displacement of the ant? Because yes, even ants can travel. They might travel a little bit slower, but they can still travel. All right, so I'm just going to map it out. Here's my starting point for the ant. The ant is going to travel 1 meter west. Turns right and travels 2 meters north. Okay, so there's the distance traveled by the ant. So I'm asking you right now, what is my displacement line? That's right, it's from the distance between the start and the finish. So we want to calculate the black dotted line with our displacement formula. All right, so first I'm going to do, just going to label A and B for my vectors and then map it out. So A squared is 2 squared, 2 is my A, and then B is 1 squared. All right. 2 squared is 4. 1 squared, 1 times 1 is 1. So now the total, 4 plus 1, is 5. So to get the displacement, we want to get the square root of 5. And when I calculate it out, the square root of 5 is 2.23. Okay, so 2.23 is my displacement. And again, look at my distance. 2 plus 1 was 3. My displacement, 2.23. So again, the shortest distance between 2 points is a straight line. On slide 11 of the PowerPoint, you will see another example if you need more help. I will be available through Google Meets to go over any other questions that you have when I start to assign some of these problems. But the first thing you need to do, like I did in all my examples, draw a diagram, map out what the word problem is saying. 10 miles, 5 miles, 1 meter, 2 meters, so that you can see it. And then you can label A and B. Stick to the basics and you'll never make a mistake. Hope all is well, guys. Stay safe.